Okay, so we want this angle measured in radians, and what do we have? We have coordinates on this circle with radius 12. Okay, so we have coordinates. So what we have coordinates. We want angle. What process or processes matches that a tool that we can use? Given a coordinate, find an angle. If it's not angle, find angle measure. Okay? So nobody knows, or you're all thinking it, or something in between. Michael?
So you would first do the, let's see.
I'm just looking for a process or a tool we can use to help us with this. We've got coordinate.
So that one would be arc sine.
Will arc sine help us to solve this problem? Arc sine. Hold on, I threw it out there to him. So arc sine. What's the input into arc sine? What kind of number is the arc sine, the input into arc sine?
That's going to be the
Radian. No, radian is never a length measurement. Radian is openness.
that's never mind.
Yeah. The arc length? So the input into sine inverse is arc length? Is that right? From the 3 o'clock position. Kate? Okay, we better review this. That's right. Input. So for sine inverse, the input and output are the reverse of the input and output of sine, because we know the input and output of sine so well. After doing it for 3 weeks, then the inverse is just switching them. So what's the input into inverse sine? Angle measure swept counterclockwise in the 3 o'clock position, right? Oh no, it's going to be one of those days. Vertical distance, glazed eyes. Vertical distance, well, the horizontal diameter as fraction of the radius, or radius lengths. Is there someone really with music on right now? Please turn it off. Thank you. Okay, output of sine inverse. Measure the angle. Counterclockwise. 3 o'clock. So does that input and output fit the problem we have here? Almost, okay. But in spirit, yes, right? We have, what is our vertical distance above the horizontal diameter?
Negative 11.59.
He wants negative 11.59. Am I hearing things, or is that, sounds like I still hear headphones. Okay, I'm probably just hearing things, but. Okay, so vertical distance above the horizontal as a fraction of the radius length. So negative 11.59 as a fraction of the radius length is 12. So almost negative 1, right? Almost negative 1. Is that a valid input into sine inverse? Yeah. Okay, so now when we do that, we need to make sense of the number that we get when we do that. So you're going to put answer in radians or your calculator in radians or degrees? Well, wants radians, so put your calculator in radians. And when you do that, you get a number. We got to make sense of this number. Do you get negative 1.31? What does that number mean? Is that radius lengths? Is that degrees? Is that arc length? Is it feet? Is it radians? Radians. So how does this number relate to the picture that we have? You got a measure of an angle of negative 1.31. So here's the whole ball of wax. Can you take that number and say, oh, I know exactly what that is in the given situation, in the picture that we drew? Tell me. Who said yeah? Yeah.
You start from your, basically on the right side where your first point is, and then going down it would be how many radians it would take to reach that. Following this.
And why does negative 1.31 make sense for that angle measure right there?
That's how many radians you could fit for the,
Okay, so where does that, so there's several questions on the exam about understanding the meaning of radians. So the meaning of negative 1.31 radians, where does that number come from? An angle whose rays
sub-10 circle.
Cut off what? A whole circumference? Okay, so in this case, negative 1.31 radians is an angle whose rays cut off 1.31 radius lengths of arc length, right? So this arc length right here, does it make sense that it could be 1.31 radius lengths? So if this, our radius is 12 here, does it make sense that that could be about 1.31 radius lengths? Yeah. It's like saying 1 and like a third, about 1 1/3 radius lengths if this is our radius. Same thing with here. Right there, that's about 1.31 radius lengths if this is the radius, here, from here to here. Okay, so if you just were asking just to report this angle, the openness of this angle, you would report 1.31 radians. If you were just saying, what's the openness of this angle? Well, it's 1.31, regardless of where it is. If you were saying, what's the angle swept counterclockwise from 3 o'clock? It'd be negative 1.31, because we know that our counterclockwise angles, our clockwise angles are negative. So both kind of are acceptable answers. You just have to have the right, you have to frame it the right way, okay? So if you're just saying the openness of that angle, 1.31. If you're saying, what is the angle swept counterclockwise from 3 o'clock, then it would be negative 1.31. Yes, sir?
I'm guessing that's going to be something to keep an eye out for on the test.
No. But you should know that. So you should know like that you can just talk about openness as a positive angle, but then we have our positive and negative, depends on if we're going clockwise and counterclockwise. I can't say no for sure, but there's not a test question on that. Okay, but that's important. Okay, questions on 96? All right, so let's take this a step further to where this gets a little more challenging. And on the web work, let's look at 171 statistics. Let's see if you guys had the same. I think it was let's try number 4. No. Oh, yours are numbered differently. Let's see. This one. Where's this picture? Bear with me a moment. Thank you. Here we go. So here, I want to underscore that you can't just, well, this doesn't quite do that, but I want to give you a way to approach these, and I highly suggest that you follow my advice. Okay, so we want to answer these. So it's giving you a y-coordinate, and it's telling you an angle measure that takes you to that y-coordinate in a particular quadrant, and it wants you to find the angle. So for instance, in the first one, y is 0.35. And so that gives us 2 points in the circle. There are 2 points on the circle that are 0.35 radius lengths above the horizontal diameter. And so we want the angle that takes us to the point in the first quadrant. So there's the picture of what they're asking for in this problem. So we're at the point that's 0.35 radius lengths above the horizontal diameter. We want to find that angle right there. Okay, what tool are we going to use? What tool matches this situation? We've got horizontal or vertical distance as a fraction of the radius length, and we want angle measure. What's that? Cosine. Inverse cosine. Agree with that? Inverse sine. Got them? Was it inverse cosine or inverse sine? Sine, we've got vertical distance, and we want angle. So that's inverse sine. So we're going to do sine inverse of, can we just put in 0.35? Is that ready to go? Yeah, that's a fraction of the radius length. It's a unit circle coordinate. Okay? And we're going to do it in, now you're going to put your calculator in degrees. Okay? First put it in degrees, and let's see what that outputs. And you got what? It says to the nearest tenth, so we'll say 20.5 degrees. Okay, so now we have to ask ourselves, is 20.5 degrees, is that the angle we want in this given situation, part A? Is that angle in the first quadrant 20.5 degrees? Piece of cake, right? Quadrant 1, it's like falling off a log, okay? Never heard that expression? It's an easy thing to do. It's an easy thing to do. If you're on a log, it's easy to fall off. Okay, so, okay, next one. Next one, we want 0.85, and we're in quadrant, so here's 0.85 is right about here. And we're in quadrant 2. So there's 2 points in the circle, maybe right about there, and right about there, that are 0.85 radius lengths above. We want the angle to the point in quadrant 2. We want this angle that takes us to a point on the circle that's 0.85 radius lengths above the horizontal diameter. What is this a job for? Sine, cosine, inverse sine, inverse cosine. Inverse sine. We have the vertical distance. We want the angle. So we're going to do sine inverse of. Okay, now before we do that, what range of angles in degrees could we possibly get from sine inverse? So the answer you get in your calculator will always be between what and what when you do sine inverse in degrees. In degrees.
Negative 90 to 90.
I heard lots of different answers. So 180 to negative 180, I've heard. Negative 90 to 90, I heard. So the circle is highlighted. The angle will be this, the angle that takes us either in the fourth quadrant or the first quadrant, starting at what angle? Negative 90 degrees up to positive 90. So we talked a lot about the radian version of that, negative pi over 2 to pi over 2. But if we're in degrees, then if you ever do sine inverse in your calculator, you will always get a number between negative 90 and 90 if you're in degrees. And so you got what number? 50.2. Is that the answer to our question? No. What quadrant is 58.2 in? So what? It gave us the first quadrant angle, right? Because we said it has to be between negative 90 and 90. This is greater than 90 over here. So it gave us, it said, oh, 0.85, well, that's this angle here. I'll do it in red. This angle, 58.2, is the one that gets me to 0.85 radius, fraction of a radius above the horizontal diagonal. So how are we going to use that to find the angle we want, which is to get to that same height in the second quadrant?
180 minus.
Okay, 180 minus that. Jenna.
An alternative way is 58.2 plus 2 times 90 minus 58.2.
Okay. Yeah, so there are more than one way to do that. Do this. Was there a hand in the back? Yeah, please. Okay, can we just add 58.2 plus 90? Will that work? Okay, if we did that, it would take us, actually, 58.2 plus 90 would be like this. Well, that's not perfect, but that was a little bit too much, okay? So it would take us to, because that's a right angle all the way to there, so that's not going to get, do you see that won't work? Okay. Other comments? So what about the 180 minus 58.2 suggestion?
Yeah.
So we recognize that here for our terminal side, this amount of openness to the x-axis, by symmetry, because this height is the same, is also 58.2 of openness here. And so if we go 180 minus the 58.2, that'll give us the angle we want. So you could find that with a calculator, or you can just let web work do it. So 180 minus 58.2. Okay, more practice. Here we go. Any questions on that one?
Can we subtract 90 and then add 58.2?
You want us to 90 minus?
58.2.
Okay, that gets this one.
Then plus 58.2.
Then no, plus 90. Because if you take 90 minus 58.2, you're getting this angle right here. And you want to add, and that's the same as this, right? So you want to add 90 plus that angle that you found to get this black angle. You see it? Okay. So yeah, another way to do it would be take 90 minus 58.2, take that result, add it to 90, and that would take you all the way to here. Okay, see if you can do this. So negative 0.55 is right here. That gives us 2 points on the circle. 1 point about there. 1 point about there. And we want which quadrant? The quadrant that takes us into the third quadrant to the point that's negative 0.55 radius lengths, or fraction of a radius length below. So this is a job for what? Sine, cosine, sine inverse, or cosine inverse? We're still dealing with y coordinates. We've got as a fraction of the radius length, so we can put in negative 0.55. And what do you got? Does everyone get that? Okay, do you recognize what angle you just got? Do you recognize in this situation, in this visual situation, can you see what angle you just got? Zach, tell me.
What?
Tell me what angle we just got in this visual situation. What is the negative 33.4? Can you describe that to me?
Like the angle of the openness of it, or?
Yeah, like how would I draw an angle of negative 33.4 into this picture?
Just like what you did. For negative, you're going to draw another line in your corner for it.
From here to where?
Straight to that long dot.
Like that? And then what's the angle negative 33.4? So is it like this one, or is it
It's going to go from the 3 o'clock position down.
there? Okay, so now, how are we going to get the black angle? How are we going to get the black angle that I drew theta? From this blue one, negative 33.4. So we're using reasoning and symmetry, not memorizing a formula. Memorizing a formula will not get you through every type of problem that we will have, okay? Including the exam. So use reasoning. Forget about memorizing a formula. What is a way we can get that angle theta? Angle measure theta. Jacqueline.
Take 180 and then
Okay, and so you're seeing go 180 first like this, and then an additional 33.4, is that what you're saying? Okay, so she's seeing that this, by symmetry, is the same angle as this one over here. So I can go 180, half a circle, plus that additional 33.4, and that'll take us to this point. Anyone see it a different way? That's valid. So 180 plus 33.4. Anybody, so you agree with that? So in the previous class, someone just put in positive 0.55. And what they got was positive 33.4. They got this angle. So then they said, oh, well then this is a straight angle right here. This is straight. So I just do 33.4 plus 180. Just ends up being exactly the same thing. Questions on that one? Okay, last one. You guys do it. Here we go. A quarter of the way. A quarter of the way down. So this is negative 0.25, or a quarter radius length below horizontal. Okay, so who wants to take me through it? Sean, did you get it? Or how would you start?
I don't.
That's fine. How would you start?
Inverse sine of negative 0.25.
Is that what somebody else did? And what does the calculator give you for that? Negative 14.5. Okay, we should have identified what angle we wanted. So we want the angle in the fourth quadrant, starting from the 3 o'clock position, that gets us to the point on the circle that's a quarter radius length below. So, fourth quadrant, it's going to be this. Oh, wow. This angle right there. And what is the negative 14.5 angle in this situation? Yeah, tell me.
It's the angle in between the 3 o'clock position and then the line you drew.
Rotating which way?
Clockwise.
Clockwise. This one. So now we look at this situation and we say, how am I going to get the angle I want? Yeah, Aaron.
You have to use the whole rotation.
Whole rotation, which is how many degrees?
360.
And what will I do to 360 to get theta?
Try it.
Good, yeah. Jacqueline, is that what you're going to say? Take a whole rotation, subtract 14.5. Okay, so we're already seeing that it's like kind of each quadrant 2, 3, and 4, we kind of treated them all differently. We treated them all differently in terms of how to get that angle we wanted. Okay, and that's only a little bit of so now if we start rotating from a different point on the circle and maybe we rotate clockwise or counterclockwise, well then all bets are off. You have to be able to reason it out this way. Okay, and we'll do some examples like that. Any question on this Wilbur problem? Okay, do you want to do the inverse cosine version of this problem? And they said yes. Good practice. Okay. So, and then that'll give us time to talk about, so the web work had a problem or a couple problems that taught you, if you work through it carefully, it taught you inverse cosine, which is actually a little easier than inverse sine. I need to go back and get a circle here. So what is the input quantity of inverse cosine? What type of quantity goes into inverse cosine? Let's see if we learned anything. How about Cameron? Can you tell me what we put into inverse cosine?
The height above the horizontal diameter.
Height above horizontal diameter. What do we think? Becca, agree with that? What would you say?
Vertical distance to the right of the. I'm sorry, the horizontal distance to the right of the vertical diameter.
Okay, so she wants to change it to horizontal distance right of vertical diameter. You want to change your mind? And in what unit is that? Fraction of radius. This will be the same as the output of cosine. And then what will cosine inverse give us? So we're going to give it some fraction of a radius to the right and left, right? We're going to give it some number from -1 to 1. And what is it's going to give us back? What will it give us back? Angle measure. Swept counterclockwise from 3 o'clock. We know we have to restrict the range so that we get only one angle measure per horizontal distance. So we need one angle measure per horizontal distance. What range does that? So we need one angle measure per, so for any x that we pick here, from -1 to 1, we want to get just one angle measure. The logical choice is, for the range, 0 to 180. If we go from 0 or 0 to pi, we go from 0 to pi in radians. There's just one angle between 0 and pi for any x value you could pick between -1 and 1. Okay, so now x is 0.2, quadrant 1. Here we go. There are 2 points that are 0.2 radius lengths to the right. One is in quadrant 4, one's in quadrant 1. And so we want the angle in quadrant 1. What are we going to do? How are we going to get that? Dan, any idea?
When we use the inverse sine after which we reverse degrees.
Okay. inverse sine or inverse cosine? We've got a horizontal distance.
Well, yeah, it would be inverse sine. Oh, I'm sorry. Inverse cosine.
And then we need the input into inverse cosine will be in a fraction of the radius length, which is what we have, 0.2. And that should give us exactly the angle we want, right? First quadrant is easy. And what is it? 78.5. Questions, that's easy, right? So what's more interesting and more harder is these other quadrants. We got to get these right. Okay, so let's do quadrant 2. Negative 0.25. Okay, there are two in quadrant. There's one in quadrant 2, a point in quadrant 2, and a point in quadrant 3. And so we want this angle here, the quadrant 2 angle. That takes us 0.25 radius lengths to the left. Or sorry, the point in the circle. Freddie, get me started. What am I going to do?
We're going to use the inverse cosine
Okay.
of negative 0.25,
Okay. We're going to get
which is 104.47.
104. That's what your calculator told you, huh?
Yeah.
Nope. Your calculator did not give you 104.47. Yes, it did. It sure did. Sorry, my fault. Absolutely, it did. Yes, it did. Okay, equals 104.47.
Oh, wait, I give you that.
I thought you. Quadrant 2. So, is that the angle we want? Yes, because the output gives us an angle between 0 and 180. And we're in quadrant 2, 0 and 180. Okay, good. Next one, negative 0.9 in quadrant 3. Here we go. Here it takes a little bit more work on this one. So here we are at negative 0.9. Gives us a point about there. And so we want the terminal side through that point, and we want this angle. Okay, now we're getting more interesting here. Can you find that angle? Pretend it's a test question. Go, everyone do it. Can you find that angle in degrees? Okay, help me out. Here we go. Nathan, what am I going to do?
So do the inverse cosine of negative 0.9,
Okay.
which gives you 154.2.
All right, and can you explain in this setting here, this context, what is that angle 154.2? What does that mean?
That it's the angle swept counterclockwise in the 3-point position when the focal distance to the right, or when the horizontal distance to the right vertical diameter is negative 0.9.
All right, well said. But which angle is it? So that was very well said. But is that the angle theta that I'm drawing?
No.
So
It's the angle between, or it's the angle in the second quadrant.
that has that same horizontal, right?
Yeah.
So it's to there, right? Because we know our range of cosine is? Right. So this is the angle we just got. The red angle is the 154.2. So now somehow, there's more than one way to do it. We got to figure out how are we going to get the angle we want. So who's got an idea? How can we do it? This Sean over here. Tell me how to get the angle we want.
180 minus the 154.2,
Okay.
which would give you the small like red angle from the diameter up,
Okay.
and then add that to 180, which would give you the whole thing.
Does it work? Yeah, that's great. That works great. So he wants to do 180 minus that, which is this blue angle here. And then add that to 180. Another way. Was it your question, or?
Yeah, no, I did, so inverse cosine of -0.9 is 154.
Mm-hmm.
I just put it directly 360 minus inverse cosine of negative.
Okay, and so why does that work? Do you see why that works? What were you thinking when you did 360 minus 154 with 2?
360 is the full rotation.
Okay,
And inverse cosine of 0.9 is 154.
so you're saying is this is 154 right here?
Yes.
Yeah, so what he's saying is from here to here by symmetry is also 154. That's the red angle I drew up here. It's the same as that 154. So you could take 360 minus that, and it would give you all of that. That works too. Can't really see that anymore, but that's what it gets. Okay, so I typed in the Sean's way, but both are valid. So 180 minus 154.2. Take that, add it to 180. Okay. Finally, 0.6 in quadrant 4. Ready? Here we go. So 0.6. Takes us about there. And we're looking for this angle here. Fihia, can you lead me through this one?
Okay, so we'll do the inverse of cosine. 26. Okay, and then we get 53.1.
Okay.
So,
And what is that? What's 53.1?
53.1 is the equal measure of the point that has 26 that is like the horizontal
Yeah.
distance above the vertical diameter.
We're talking about up here?
Yeah, in the first quadrant.
Good. So that 53.1, why? Because the output of cosine inverse is from 0 to 180. So we're going to get an angle between 0 and 180 that has the same horizontal distance as our point. That must be first quadrant. So that's 53.1. How are we going to get our angle? Keep going, you're doing great.
I'll subtract it by 360.
That's right. By symmetry, that's also 53.1. So we're going to take the 360 all the way around, subtract the 53.1, we get the one we want. Okay, any questions? So let's take it a step further here. Any questions on that? Okay, so how about it's time for our car again. What did we use last time?
Monster.
Okay. Smart car, monster truck, Lambo, or Formula One? All in favor of the smart car? With pride. All in favor of the monster truck? All in favor of the Lambo? All in favor of the Formula One? Monster truck wins. Is that what we did last time?
No, you did the race car.
Race car, okay. Good choice. All right, so here it goes. So it's going to start at the 3 o'clock position. It's going to go in a circle of 8.5 feet. And it's going to stop 6 feet to the left of the vertical diameter. Something like that. Maybe one more tick. Come on. All right, that's fine. Okay, so here's the setup. Our remote control car drives in a circle with radius 8.5 feet, starting from the 3 o'clock position. After passing the 9 o'clock position, it stops 6 feet to the left of the vertical diameter. How far did the car travel around the circle in feet? Can you do it? Pretend it's a test question. Okay, pencils down. Let's do it. Pencils down. No more writing. Here we go. So this is actually, so in terms of cosine, this would be negative 6. So we have horizontal position. We want arc length, which we know is almost the same as angle, right? So if we have horizontal position and we want angle, what function is that? Inverse cosine. What kind of number goes into inverse cosine? Pencils down. Pencils down. They're not in your hands. Drop them. Okay. What kind of thing goes into cosine inverse? Fraction of a radius length. So it would be? You could do positive or negative. If you do positive, you just got to know what you're going to get, all right? But we want, this is truly negative, right? Because we're to the left. We're to the left. So cosine inverse of negative 6 over 8.5 is? Anyone have that? Oh, and so do we want to work in degrees or radians on this problem? Radians. If we want arc length, we're far more convenient to work in radians. Does anybody have that radian measure? 2.35 sounds right. Okay? And so we need to know what that is. Is that this red angle I have here to the third quadrant? No, it's the angle between 0 and pi, so it's the blue one that I've shown here in the picture. So that is our 2.35 to the point in the second quadrant that's also 6 feet to the left, right? So the calculator just thinks, oh, you mean 6 feet to the left, 6 over 8.5 feet to the left in the second quadrant. So I'll give you that angle, 2.35. So how are we going to get the one we want? So there's different ways to do the question? Oh yeah, go ahead.
So you could do is take 2 pi minus 2.35.
Yep, that'll work. Because this right here, this dotted line, is also, from there to there, is also 2.35. And we want a whole circle less that will give us the red one. So that's one way to do it. You can do 2 pi minus 2.35, which will be the angle I have shown in red is in radians. And then we want arc length. So I'm going to do times 8.5. Who's got it? Tell me what you got when you did that. 33. That's what I'm hearing. Is that right?
Yep.
Questions? Understand it. That's what we're doing. Okay, so now go back to the front page, and in the space down below the table, we'll do another one. Here we go. Who knows what's going on? A ladybug. Listen. A ladybug. So the fan radius, a fan blade is 45 centimeters long. Okay? The ladybug starts at the 6 o'clock position and it rotates clockwise. Here it goes. Watch. Ready? The ladybug starts at the 6 o'clock position. The fan rotates clockwise. When the clock passes the 12 o'clock position, it stops 10 centimeters above the horizontal diameter. So this dimension right here is 10 centimeters. Starting from the 6 o'clock position, here's the trip of the bug. Around like this, all the way to 10 centimeters above, back in the first quadrant. How far did the bug go? How far did the bug travel? Go. I said the fan blade is 45 centimeters. The length of a fan from the center out to the. Is that got it? Questions?
I figured out the
Oh, it's not.
Okay, so 10 over 45 is the vertical distance as a fraction of the radius length. Vertical distance. And we want angle. Eventually, we want arc length. So which are we going to use? What are we going to use? We're going to do what process on vertical distance to get angle? He wants inverse sine, agree? Yep. Arc sine. That's how we're going to start. And we're going to get an angle for that. What angle do we get? 0.22. And we got to know what that is. Is that centimeters? That is radians. That's openness. And in our picture, what angle of openness is that? We know that this is the angle between negative pi over 2 and pi over 2 from the 3 o'clock position. So that's this angle right here. 0.22 radians. We need, in blue, we need this angle. So your formulas don't work in this problem. You have to understand what's going on. It gave us 0.22 radians, which is our 3 o'clock positive angle, and we want the blue one. There's a way that seems most obvious to me, but there are more than one way to do it. So to me, what seems obvious is I want to go all the way 3/4 of a circle and go back 0.22. So I want to go 3 pi over 2, and I want to subtract my 0.22. That seems easiest to me. Anyone else do that? Okay, that seems like the easiest way to do this to me. I want to go 3/4, takes me to 3 o'clock, but I don't want to go that far. And this is how much less I want to go. That's my angle measure. And that's how many, so that's how many radius lengths the bug traveled, since it's the radian, or radius lengths on the arc. And so each radius length is 45, so multiply by 45 to get centimeters. Okay, so good example, you can't use a formula for this problem. You got to know what's up, and you got to be able to reason it out. Okay, so everyone write 20 out of 20 on your quiz? It's your attendance for today, participation? All right, can I fly through a web work graph problem? Questions on this? Okay, let's do one. Here we go. All right, I want to get you out on time, okay? We'll try this one that has the lowest success. Here we go. This one had the lowest success. Let's do this one. Is this the same one we did last time? Similar. Okay. All right, here we go. Strategy is first. Oh, brother. Changes font size on it. Messes up on me. Okay, here we go. So first thing, what do we do first? When we have a graph and we want to write its equation, what comes first? Midline. Midline is first. So here's our form. A sine of b parentheses x plus c parentheses plus m. Midline is first. What's the midline? 0. Amplitude? 1. Okay? Next we want to find b. B comes from the period. So we need to pick the period off of this graph. So our period equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think it's 14 in this graph. So midline to midline, but you'd have to skip one, okay? So if you're going to use the midline, that's only half. you need to do it again, right? So that there's a sine right there. And this is period of 14, which means that b times x, we want the argument to reach 2 pi. So that's when we reach 14 and x, we need the argument to reach 2 pi. So what angle measure does bx need to reach for one cycle? That needs to achieve 2 pi. Everyone hearing that?
Yeah.
That needs to achieve 2 pi. Okay, and so then we need that to be 14. So b is 2 pi over 7. No, 14, 7. Oh, just seeing if you're paying attention. So that's pi over 7. Okay, here's the hardest part. Don't pack up and turn your brain off. This is the part that's harder. So, we want to write it as a cosine or a sine? Let's write it as a sine. As a sine, here's what you do. Start by sketching the unshifted sine. Okay? 1, 2, 3, 4, 5, 6, 7. Okay? So here's unshifted sine. Find the closest one to that. The closest one to that is this one back here. So the one we're trying to draw, is it, so thinking about this input increasing like this, does our cycle start before or after? The one we're trying to write the equation for this. Does it start before or after unshifted sine? Before. So is it ahead or behind? It's ahead. It's ahead. It starts first. It's ahead. How much is it ahead by? 1, 2, 3, 5. Ahead by 5 units of input. So its angle is 5 greater or 5 less? 5 greater. It's ahead. The one we're trying to draw is ahead of an unshifted sine by 5 units. It comes first. So its argument angle is 5 more. So C equals plus 5. So this would be A is 1. 1 times sine of B we found was pi over 7. X plus 5. And the midline was 0. If you want to ask me a question about this on your way out, please stop me. Okay?
Did you want me to collect all the quizzes?
All right. So here's the thing. Yeah, turn your quizzes in. All right, everyone, listen. Today's recitation is optional. It's study and review session. If you're going to go though, go right now. Don't wait till halfway. Go now if you're going to go. And then Thursday recitation.